Thanks very much. It's a real pleasure to be here. And my name's Jon Morse, and I'm at the BoldlyGo Institute, which we started working on about 5 years ago in earnest, and incorporated in 2013 and got our IRS certification in 2014. And the whole goal of BoldlyGo Institute is to try to do what we'll call world-class, or for those in the field, decadal survey class science with private funding. And it's both as individual standalone missions or in public-private partnerships with NASA and other space agencies. And so this is my wonky budget graph, which is showing the change in the budgets and percentages since the Bush administration back in 2008. And there's Earth science up here, which did well in the Obama administration, and this is the drop in the funding in the most recent budget request in the new administration. Space science is here in red, which is a combination of astrophysics, planetary science, and heliophysics, and summed together. And it was flat for basically 8 years, and only recently has started to go up, and that's mostly because planetary science has now gotten a lot of budget increase at NASA. Nevertheless, as we just saw in the slide from the previous talk, there's so many destinations to go in the solar system. This budget could go way up here somewhere, and you would still lack resources to do everything we would like to do in exploration. And then, here's astrophysics down here, actually several percent below the budget it had in the Bush administration, and is highly resource constrained in what it can do. And so BoldlyGo's motivation is to try to bring in external resources, basically in order to increase the flight rate and accelerate discovery. So some of our limits are that, basically 100% of the advanced spacecraft are flown by NASA in this country. There are CubeSats now, and other people looking at concepts that would be non-NASA, but if you're doing decadal survey type missions that are in the class of Explorer missions or Discovery missions, NASA has a monopoly, basically. And having served on the selection boards in SMD, and everybody watches the competitions every time there's an announcement of opportunity and a down select, there's always way more ideas and selectable missions than there is money to do them. So what we want to do is take advantage of a lot of the activities that are happening in commercial space, and look at philanthropic models in particular, but other models as well, for doing large projects. So here are just some examples of how launch services and the costs have come down, and the frequency will go up. And so the opportunities to get into space should increase in the future. And Martin Elvis tomorrow is going to speak in more depth about how science should be taking advantage of the advances in commercial space in order to lower the costs of doing missions. And then in addition, ground-based astronomy, as we heard from Alex, has a long history of doing privately funded significant assets at the frontier of science. And this is true also in medical science and medical research. Despite the NIH's $30 billion budget, we still put a lot of private philanthropy into medical research. And there are large ground-based observatory projects which are billion-dollar class now that are privately funded and through consortia of partnerships. We could build 2 Keplers for that, right? And I use Kepler as an example because everybody knows how extremely impactful that mission is. And it is within, it's always been that space missions cost too much. But They don't cost too much, and they're within the history of philanthropy and other types of revenue generation in order to do frontier science. So even locally, there's more evidence. The Simons Foundation locally has funded the Center for Computational Astrophysics. It's now being led by my friend and colleague David Spergel. And that's right down here in Manhattan, and it's with a Center for Computational Biology and I think some other fields as well. And this is a significant, many millions of dollars of investment going into basic research without a commercial product in mind. And so when I talk about the prospects, this is sort of our, in some sense, our value proposition. We're here at BoldlyGo to accelerate world-class scientific research. We want to transform the funding model for space science and exploration to augment and enhance the national portfolio, not to replace it. We're not going to have $5 billion per year like Science Mission Directorate, but since even with their budget, they are resource constrained, we can help advance discovery in this way. We want to redefine some of the management of advanced science spacecraft and believe that the commercial paradigms have a lot to offer there. Engage faculty and students. This is natural and happens all the time on NASA-funded missions, and we certainly want to do that and create tangible impacts in public engagement, including things like citizen science and so-called participatory exploration. So you recognize this planet. This is Mars, and there's a lot of interest in understanding Mars and sending people to Mars. Right now, we've spent a lot of robots to Mars. Here's Curiosity rover image showing how interesting and in many ways very terrestrial looking the layers are in this geological setting, and it is investigating Gale Crater for its mineralogy and also whatever evidence it could have for having water in the past. And if you have water, that's one of the ingredients, a main ingredient for terrestrial-like life forms to have formed. And so even with this sophisticated robots, and there's another rover coming in 2020, we would still, this is an example of a project that we have. We would like to look at returning the first samples from Mars by flying through the atmosphere, having dust collected in aerogel like they did in the Stardust mission with the comet tail, and come back without going into orbit and without landing. And this is a way to keep that surface, the sample return cost down. It doesn't do everything we would like to do in sample return. We would like to land on Mars and dig, and this is what the Mars 2020 rover is starting to do. But NASA right now doesn't even have a plan or the funding in place to bring those samples back. And so this is something we could do to start the sample return ball rolling as soon as possible, and we could be the first privately financed science mission to Mars, the first round trip, and the first to bring samples back for understanding Mars, but also this would be an important legal hurdle for the whole commercial materials business. People who want to go mine asteroids rely on the legal framework in order to own the materials that they extract so that they can create something, a product out of it, something of value. Our goal is to do scientific investigation with our Mars dust, but we would at least be able to establish the precedent of a private company owning the materials extracted from an extraterrestrial source. So that would be an important thing to do in the future. Another one of our projects, as just mentioned, a modest space telescope, only a ½ meter in diameter, can resolve the habitable zones in Alpha Centauri, around Alpha Centauri A and B. We have a project called Project Blue, which is to observe with a coronagraphic telescope of modest size in order to look for Earth-like exoplanets in the habitable zones around Alpha Centauri. And this is something that using, again, there's a lot of industry experience with this aperture of telescope in the Earth observing marketplace. And so we can leverage that experience and how they've brought the cost way down to put a sophisticated optical system in space in order to do a coronagraphic experiment, first of its kind, that would have a huge impact in science impact moving forward as we plan larger telescopes in the future. I should have also noted here, here we are working with Lockheed Martin and our industry partners. We also have a Space Act agreement with NASA, which Alex mentioned earlier. NASA is interested in having private resources devoted towards achieving science goals that are aligned with the agency's strategic plan. And so that's what we're trying to do, is augment the flight rate. This is another example of the same thing. And then finally, this is the iconic Hubble image of the Eagle Nebula. And this is what happens when you upgrade the instrumentation on Hubble. But there are limits to even Hubble's, where you can go with Hubble's capabilities, even if you were to service it again. And so at some point, when I was astrophysics division director, a lot of people external to the United States would say, when are you replacing Hubble? And we're not really replacing Hubble. We have the James Webb Space Telescope that the astronomers have asked for, and now the new mission called WFIRST, which is in the near infrared. We're actually not planning a Hubble-class replacement telescope that observes in the light that our eyes see. And so this is another area where there is an opportunity to do something that could be quite iconic and with high visibility and with high science impact, that to fill a gap in the portfolio and to take the budget burden off the space agency while they're doing a lot of other things, while they might try and do a starshade and the next generation of large optical or infrared or X-ray telescopes. And so, what if we were able to privately fund a space telescope in the 2020s and operate it the same way the government does by making it broadly available to the community? And then there's this. The model of having private resources devoted towards space missions doing basic research on this target may become more valuable. When the government is now pulling back in its investments, our model is set up to do this as well, if people are interested. And we think that this is an area which may attract a lot of interest from people of significant means in the near future. So the main challenge is funding. There's no question about it. That is the thing I spend most of my time on. We have science teams on our projects, and they look kind of like space missions you're all familiar with. They have university partnerships and industry partnerships, and the funding is the hard thing. So what we produce is science. We create knowledge, fundamental knowledge, without an application in mind. That's, in our heart of heart, that's what we as scientists do. There's also the opportunity, as was mentioned earlier, for legacy, for people who might want to invest. And there's, of course, the education. And there's other aspects too, but those are the three main ones that attract people to these. So the basic research aspect makes it difficult to raise capital through venture capital because there's no return on investment. And so it winds up being philanthropy. If we could open this door, I guarantee there is a huge potential out there. And so we have to figure out how to generate enough funding revenue as a result of flying the mission in order to make it possible to attract investment. One of the ways is with prizes. Prizes and data buys could work. Could be foundations doing a prize, a science prize of some sort. Another one could be NASA doing prizes and saying, we will have a certain amount of money, but it needs to be commensurate with the effort that's going in. And so you can't have a prize that's smaller than the cost of doing the mission. The cost of doing the mission has to be less than the prize so that there's a return on investment. But if we could figure this out in the right circumstances, I know that we could unlock this huge potential. In addition to philanthropy, we can generate revenue on all these missions through different kinds of sponsorships. We can look for dual-use technologies and missions that serve both science and commercial. That overlap is not huge, but it is there. Usually the scientists have very specific instrumentation they want to do, and collaborations and partnerships with universities and international space agencies are a natural thing we already do in this business, and pulling together the resources of a number of different institutions could enable meaningful missions, but you have to have missions that have broad utility so that it serves all the different partners. And the amount of money, for example, universities can drop on a project in a short amount of time, say over a couple of years, is fairly limited. If you're trying to raise money on a campus for a large building that's $80 or $100 million, that takes some cultivation and could take years to accomplish. And so in general, universities know how to put $1 million or several $1 million into proposals. So that level of funding is quite common, but going 10 times that is something that's challenging, and there'll be more on that tomorrow, I believe, from Betsy talking about the context for university participation. But there's something to keep in mind when we talk about high net worth individuals. The estimate is that there's roughly $4 trillion of wealth out there in high net worth individuals and the family offices, many of whom have major research foundations. We've heard a lot of the names being mentioned who work through foundations. We hope this proliferates and that more and more science and basic research is funded through this mechanism and by having wealthy people put investment back into basic research, and we think private space science is prime for someone. But so far, what we have found is when we approach a lot of people, they say, well, isn't NASA doing this? Somebody already kind of alluded that when they said, name some topics, projects that you would do with private funding. And, I say exoplanets, or dark energy, or gravity waves, and they always say, well, isn't NASA doing that? And so, yes, NASA's doing that, but there's room to do a lot more on those kinds of targets, like Project Blue, which is going to go do a specific experiment on a specific target that NASA's not planning in its portfolio. It's NASA is taking a survey approach with bigger missions later, starting with W first. So that's all I have, and I'll be happy to answer questions. Thank you. Yes?
Hi, Erin Beagle, BBC. I have to be honest, it scared me a little bit when you said that you guys would have the first privately held samples from Mars. Do you expect that you'll be the only people on Earth with samples of Mars in your hands, and what are the big, wider implications of that? How do you give those to people for research? Do you give them to people? Do you charge money for researching those?
Those are all great questions, and the short answer is yes. So we'll be a consortium that includes, first of all, NASA, and part of NASA's role in the Space Act Agreement is to help us with planetary protection and curation of the samples. But it is common for the samples returned by spacecraft like Stardust, like OSIRIS-REx in the future. They bring those samples back. They're held the lunar samples. And they are sent out to research institutions through calls for proposals. And we'll follow a similar model. And our hope is that, Arizona State, one of our main partners on that mission, may play an important role in the curation and the way the research will be conducted around the world. We believe there will be global interest in analyzing those samples. Exactly, and that has already been something we've heard feedback on. So, exactly, and what we're still exploring is, do you get the do you raise capital, get the samples, bring them back, and then sell them? And then how much do you generate in revenue? That's not really the way we'd like to look at it. We would like to have our partners identified at the beginning first. Next question.
I'm wondering how to avoid people who would use private space science as a justification in like a constrained budgets. If I'm an appropriator and I see you have this Project Blue, why does SMD need this cut out of the CPS budget? What are the how do you deal with the
right. Correct me if I'm wrong. I'll try to reword that a little bit. It's like, okay, if private industry or private investment steps in to fill gaps, then appropriators would feel, oh, hey, we don't need to put money in. And so there are a lot of people who point that out and worry about a drop in their government appropriations if the private sector is successful. I just plainly say, I'll repeat what I said before, we're not going to raise enough funds to replace SMD at NASA, not even close. We're just picking specific projects, and even a couple decades from now, I still see in basic research that the government will play the lead role and provide the majority of the funding. But if the private sector can augment, because there's way more content than NASA can afford, that's what we're trying to do, is augment and increase the flight rate. Betsy, did you have a question?
Yeah, because I think that this question about samples is a proxy question for privately funded data in any area of science. And it's easier to talk about real stuff and like how do we apportion it and send it around. But I do think one of the, John and I've talked about this, one of the really interesting questions about privately funded science of any sort is how, it isn't the upfront, it's the back end. How is that data compared to what we're used to in publicly funded science? How does that become part of the knowledge enterprise?
Right.
I think it's not an answer, fully answered.
Yeah, our BoldlyGo's stated intent is to be like the government in this respect. Make our data publicly available in an archive, like from a space telescope. We want citizen science. We want the broader science community working on this, and we believe in the value of having multiple investigators. But it is also normal on a space telescope project to have a certain proprietary time to make sure you've got well-calibrated data and you're not just putting stuff into the public domain that people can't make anything out of. And so, I can tell you we intend to follow the best practices in the government. This is becoming a condition for NASA's participation, by the way, in some of their different international partnerships. Anyway, Sandhya?
Well, I just wanted to comment that the relationship between private funders and the government funders is much more evolved in the biomedical area. It's much more mature, and the foundations in particular have forged for themselves a space where their funds are important, critical, valued, and very structured. This does not exist in the private space enterprise. And so it's an evolving area, but for example, foundations provide seed money for innovative early stage new ideas, faculty funding, graduate stipends, and they have a space that works well. This is still evolving here, and I don't see any reason why it should not evolve closer to that model. And then, you deal with the issues as it evolves. But it is brand new, so, there's nothing for us to go on at this point except that as a model.
Yeah, I mean, LSST is a prime example. Private funders put in the money to fund the mirror and to prove that it will be successful, and then DOE and NSF pitched in a good fraction of $1 billion because it was de-risked. So I think it can be done, and then private and government partnerships can actually flourish.
Right, I think one of the missing pieces is nobody has really attempted to present this to the private funder community as a body. They really don't know enough about it to feel confident giving funds, and so that's a piece I think that needs to be addressed.
So I think we should thank, it was very interesting. And no